Good morning, or insert appropriate time zone for where you are today. How you all doing? Free Duchess, I'm only here for the dog intro, then I'm out. Suki literally just got up, literally as I started the stream. How you all doing today? So hi, my name's Mark Mandel. I am a developer advocate for Google Cloud, founder of the Agones project, which we're talking about today. So you'll see some descriptions and links below. If you're not familiar with that project, it's a project for running dedicated game servers on top of Kubernetes. It's open source. You can find all the links in the description below. And we're going to be working on a fun thing today. I've also got a nice cup of tea with my Crayon's Crayola mug. You can't see that because that's really blurry. This is good because I'm still coughing just a little bit. I've been sick for a few weeks. But anyway, what are we working on today? I think we're actually working on something really neat. So let's actually, let's pop over here. We'll make that a touch bigger. So the last few streams we've been working on this thing called game server fleets. So basically having a large group of warm game servers that are already running across a cluster of machines. And we've set up the work for this already, right? So we've already done the work to set up a fleet of machines. Actually, why don't we show a little demo of that just for giggles. Blah. Of course, I have a MiniCube cluster that has just died. So why don't I just blow it away and start all over again. That'll be fun. So I'll have that running in the background, and that can happen in the background. So we'll talk about what we're actually going to work on instead. All right. So and then we'll come back while that's running. So okay. So this is the design ticket that we're actually looking at. It's on GitHub. It's issue number 70 if you want to follow along at home. And we wanted to be able to set up basically a group of, say, like maybe 10, probably actually thousands of dedicated game servers that games could then connect to. We've done that work. That's up and running. I'll show you a demo once I go back and make sure that my Kubernetes cluster is already up and running. And what we want to do today is this piece down here, which is allocation. Basically, I want to be able to say, hey, that big group of game servers that we have available, can you give me one, please? And it's going to, in some way, shape, or form, statically probably lock that and be able to say, cool, give me one of those game servers out of the set that's ready. And there's some interesting questions there around like what happens if like a game server is not available, how long do we wait, things like that. But, excuse me, but we'll work that out as we go through. Actually, I can tick that one because that's been merged. That's cool. Cool. So the idea here is what we're actually going to do is create what's called a custom resource definition. So if you have a look, say, for example, up here, this is a configuration. If you're not familiar with Kubernetes, quite often you write YAML files or some kind of structured thing like JSON as well. We can do that as well. And whatchamacallit. And Kubernetes out of the box has a series of nouns, basically these resource definitions like deployments and services, things that it comes with it. But you're able to extend it with these things called custom resource definitions, which enables you to provide your own nouns, right? So we've used things like fleets and game servers. So Kubernetes knows how to understand those. So we're going to extend this to basically have an allocation as a custom resource definition, and then we're going to do stuff with it. We've called it a game server allocation. Okay, let's stick with that. I wonder if we want to drop that to being just allocation. But let's work with what the design was in the initial spec, and then we'll work from there. You know what? I might actually change that. Maybe I've changed my mind. But anyway, let's talk about that. Anyway, so Afraid Duchess wrote a question. Quick side question: do you dual boot? Do you have any setup YouTube videos you'd recommend? Afraid Duchess, I used to dual boot a lot. I run Linux as my operating system. I used to dual boot back when I used to run Linux on my gaming laptops, but now I have a separate work laptop, so I don't bother. It's really straightforward to set up dual boot though. Just install Ubuntu over the top of Windows and it'll set it up pretty much for you. Although you might want to shrink the partition first. Anyway, I digress. All right, so let me see if that's up and running. An error has occurred. Ah, man, what's going on here? So cube ADM and it's sudo. Ooh, that's fantastic. Yes. All right. Let's see what's So I have Docker images. I don't have any, sorry, Docker images. That all looks fine. Let's actually look and see if that's, oh, of course things are just gonna break because, that's really weird. MiniCube has not failed for me. MiniCube version. Oh, so we may be doing something very different today. We may be trying to fix MiniCube. Bear with me one sec. I may have actually just accidentally updated MiniCube. What do we want to do? What do we want to do? What do we want to do? Let's try this real quick. Let's run the test cluster again just for giggles and see if it will solve that problem. Just to see if running it twice, and then I'll worry about it later. That would be nice if that would actually just work. That figures. Of course, as soon as I... MiniCube is for work on Kubernetes in local. Yes, Newbard, you answer exactly the right question. Yes, so I run just a MiniCube cluster just for doing local development. I find it quite nice. I could point at... Oop, this is looking promising. I could point at a... I use a Google Kubernetes cluster. A Google Cloud Kubernetes cluster too. That's also an option, but I find this is faster. Just a little nicer workflow. Please work, please work, please work, please work. While that's happening, I'm just gonna pull up MiniCube releases just in case I need to downgrade this because I feel like I have some scripts that may have updated this recently. When did that come out? 7 days ago. Yeah, that may be it. Hold on, let's have a look. That's 2.6. Maybe we grab... Oh, come on. Do what I want. Otherwise, this is going to be really annoying. Tell you what. There's my dog running around in the background. Cool, let's do that. We're just gonna overwrite MiniCube with the old version. And then, this is fun. All right. There goes my dog. She has to bark at something, right? There we go. All right, let's see if that makes any difference. Yep, don't care, there's a new version. Okay, so you know what? While that's spinning up, we can do some work. And we'll see if that works. And if it doesn't, we'll come back around again. So creating our own custom resource definitions is kind of fun. Where do we want to start? So I think we'll start here. So if I have a look in install, so we're using Helm for our installation, but we're just going to be creating YAML. So it's nothing too special. We actually have a variety of CRDs here. So I'll have a look at a game server, for example. So strangely enough, there's a resource or a kind for creating resources. So I'm going to actually just copy this for now, and we'll edit it. And we'll step our way through it. So we're going to call this an allocation. I'm actually going to call it an allocation. I've decided. So here we go. So kind is custom resource definition. We're going to call it allocations. The name usually is in plural because that's just the way Kubernetes just likes it. Nothing more than that. That's all fine. That's all Helm stuff that I'm not going to mess with because somebody else wrote it. We actually have this thing called grouping and versioning. This basically says like what part of a system does this belong to? So all of my custom resource definitions are called allocation. Are under stable.agones.dev, which means I could do like beta or like dev versions, that kind of stuff. Everything's v1 alpha 1 because that was the version I decided on. Scope is namespaced. I've actually forgotten what this means. So let's go have a look because I've forgotten. I've actually forgotten what that means. I would have chosen that a while ago. Let's have a look. Scope. It doesn't say. All right, well, you know what? This is where we can actually go and have a nice look at how you can look up exactly what's happening. Let's go into reference. I am using actually Kubernetes 1.9, so I'm going to drop down to that reference. If we go into reference and we look at the actual API, this is actually really useful, especially if you do any programmatic stuff against Kubernetes. This is like I live in here. And you can start to see exactly what things are what where. So here we have, so we're going to create a custom resource definition so we can actually have a look at the reference. You'll see things like object metadata. If you've done anything Kubernetes, you might be doing some stuff in there. Let's have a look at our spec. So that's where we are in here. So scope indicates whether this is cluster or namespace scoped. Oh, that's right. Okay, so what this means is when you create things in Kubernetes, quite often you put them in a namespace. And that means that if different things in different namespaces means they don't necessarily able to see each other. And if you delete the namespace, the whole thing gets removed. It's actually like a network namespace essentially. But you can make things that are cluster-wide, so that everything can see everything. And in this case, we definitely want this to just be namespaced. Maybe you want to group, say, if you have multiple games running across your Kubernetes cluster, maybe you might want one namespace per game, for example. That kind of stuff. So there's definitely useful stuff there. Okay, so there's a question there from Nobar64. Do you use gRPC on Agones? I do actually use gRPC for Agones. I use gRPC. There's an SDK framework that's built into the stuff that I have for game servers. And that's all gRPC based. And it's actually really nice because it means I can generate clients really easily. Just for a sidebar real quick, in this SDK section, you can see there's a Go and a C++ SDK here. Both of those are just basically thin layers above the gRPC binaries, or the gRPC clients that get generated. Okay, let's finish this first. We'll finish this first. Okay, cool. So scope is namespace. That's definitely true because we're going to do everything else is namespaced. We're going to call it not a fleet, it's an allocation. Plurals will be allocations. What's nice is Kubernetes also gives us some nice ways of saying like short names. ALC. Anyone can think of a good short name for an allocation? That's probably the best I can think of. AL, maybe ALC, something like that. Singular is an allocation. And then there's a whole validation section here too that the client can hook into. If we go back to our original ticket, let's have a look here real quick. Now, I actually realized there's a problem here in that while we've specified an allocation, we haven't actually said which fleet to get it from. So we would definitely need that. That would be useful. So actually, yeah, let's have some of that. So I wasn't doing some includes there, but we will. Do we want to do this right now? Yeah, let's do this right now. No, let me think about this for a sec. You know what? No, let's come back to this. I'm going to come back to this and not worry about it for this minute. So we can do some validation in a few places, but I'm going to get the data structure set up correctly, make sure that's working so I feel like that's okay, and then we'll come back to this and make sure we put it in there. Yeah, the validation is really nice. If you want to actually see some validation, just for interest sake, this is actually just an include that we use. Is it going to open? There we go. And so you can see things like what values are required, what types, like an array example. You can do patterns and all sorts of other fun stuff. It's pretty good. There's other ways of also doing more complicated validation. We're actually going to look at that a little bit. You can actually do these intercepting webhooks that we'll look at in a sec. But that's the short answer. Okay, so that worked. All right, cool. That worked. All right, so we just downgraded, and apparently everything was fine. I've got something wrong with the new version of MiniCube. I don't know why, but that's all good. All right, cool. So if I say kubectl get pods, beautiful. All right, so I have a feeling this is going to need to build. Build images. Let's have that run in the background too. Yeah. Okay. I'm gonna ignore that. Okay. So we'll test installing this in a second. That's fine. what we next need to do is actually define the data structure of the data we want to have in it. And we've got some examples of this, and we can sort of take advantage of those, but let's go have a look. All right, so package, APIs. So this is the interesting piece as well. So there's a bunch of tooling around doing custom resource definitions that's worth noting about. And actually, I'll show it to you now as well. And actually, I have it here because I was going to put some in our docs. This is the Kubernetes sample controller, which is literally the example. You can find it linked inside that custom resources tab we were looking at earlier. This is a really good example of doing a simple controller for watching like a foo, just a something resource that's a custom resource type. And what's kind of cool is you what's what I'm looking for is that it has. That's right. I'm looking for. It's actually got some really new. It's got new stuff in here I haven't actually seen before, which is really nice. There is code generation that happens in here. Here we go. Hack. Update code gen. Here we go. So there's this whole code gen library that gets. Here we go. Code gen package. Oh my god. There's a code generator. Here we go. Which is actually here, which generates all the Go code for what we need to build. I've already got it set up locally, so that's all ready to go. We'll step through some of it. It's not particularly complicated to use. But if you don't know it exists, it makes things really fun. So you can go in here and check it out and get to use it. So you can also use the sample code that we have over here to get started. So we've already, strangely enough, if you've hung out with me before, I have some make targets that do this already. So here we go. Here's my here's some ignore that line. So code generator, I generate groups, and then I just tell it where it is that I want everything to go. Boilerplate.go.text. That's just that's my header. Basically, it's got my license in it and stuff. Excuse me. All right, so what we want to do is create ourselves some data structures. Let's just pop back over to our design. So I do want to add, I'm actually going to call that an allocation. I don't like that. I've changed my mind. And okay, so basically we're going to have an allocation. Metadata is going to be like our standard Kubernetes metadata. There's nothing strange there. Our spec should have a fleet name. So we'll add that, and then there's some status values, which should have the whole game server inside it. Okay, so let's do that. Should be interesting. All right, cool. Where do we want to start? Okay, we're here. All right, so there's kind of a given spot for where this stuff goes. It's in this package API stable, and then so you can see, right, stable v1 alpha 1. That's like the same part of that group name we saw earlier. Excuse me. I'll have a look at, say, for example, a fleet. There's a bunch of stuff in here, so this is going to be fun. All right, so I'm going to actually steal that because it's going to give me a good starting place. In fact, my dog is standing right by my shoulder, which is kind of funny. I wish he could be in the shot. I don't know what you're doing, Doug. Come here. Okay, and things have slowed to a crawl. There we go. New Go file. We're going to call it allocation. Oops. There we go. I have a feeling that my code is compiling. Yes. Okay. All right. So I'm going to use this as our example. Actually, I'm going to steal all of this because we're going to want all of it. So there's a few different interesting pieces in here that are worth noting. So this here, these 3 lines here, this is basically the parts that tell that code generation piece what to generate. So we're telling it, hey, generate the client. Don't worry about the no status for now. We'll talk about that maybe never. Right now, I'll leave that in unless you're running 1.10. excuse me, and then this is like deep copy gen, so creates a deep copy function that we'll have run as well. So, all right, so allocation is the data structure for allocating against a fleet. Maybe it should be a fleet allocation. Ooh, I think I like that better. I think I like that a whole lot better, because maybe in theory we would have other things other than a fleet lying around. Yeah, I think I like that better. Now that we're talking about it, I think that feels better. So we're going to call this a fleet allocation. There shouldn't actually be anything to change. Yeah, sweet, cool. Yeah, let's do that. I like that a lot. Cool. All right, fleet allocation. Oh, I do like this. All right, sweet. This is pretty standard. You can kind of copy paste this bit. This will actually be a V1. Go on. It'll include for me in a sec. There we go. This is oops, apparently I just pulled in the wrong one. Every Kubernetes object has an object meta. Go on, give me, yeah, API machinery. Okay, sorry. That has a tendency to move around a little. All right, and we want to call that meta v1, which is pretty standard. A lot of stuff you'll notice everything's versioned a lot of the time in Kubernetes Grow code, so having aliases is always good. So type meta, you actually don't even really care about. Object meta is where things like the name come from and things like that, and that's really important. All right, so we want, we're going to ignore this for 1 second and just pop down here below. The other thing we'll want is a list, right? We may not get fleet allocation lists, but as a regular thing. But basically, we need a thing to be able to get out lists of values and to generate the code for that. And everything here has deep copies as well. So this will be an allocation list. Fleet allocation list, I should say. I think I definitely like that. Fleet allocation list of fleet allocation resources. And that is an array of fleet allocations. Why is that not? I can't spell? I can't spell. Okay, that's looking good. All right, so that's there. Now we need a fleet spec and a spec status. Okay, so let's just call it a fleet allocation spec and a fleet allocation status. So we can do pretty much whatever we want inside these things. Spec is usually like where you specify the user-based requirements that comes in. And then the status is sort of what's returning as the value. So spec will need a, call it a fleet name, I think would probably be accurate. So what fleet we want to pull stuff from. Let's see if this is going to be nice. It is going to be nice. All right. Type fleet is going to be a struct. All right. I'll put it below because that'll make me happier. How did I organize this over here? Let's see if I can just, yeah, I put it under my list. All right, cool. Fleet allocation spec. No, thank you. Yeah, cool. It is the spec for a, actually I'll say it's the spec for a fleet allocation. And what do I need? I need, think through. I want a string and we'll call it fleet name. And then, why doesn't it like me when I've done that? Have I done that the wrong way around? I have done that the wrong way around because I can't remember what I'm doing. And then we want a JSON of fleet name. Cool. And I think that's really all we're going to need, right? We're going to say, hey, give me an allocation from this fleet, and then it should return me an allocation. So that seems pretty good. But we'll also need a fleet allocation status. So let's just make this create that. We'll come back. And we'll drop this down below. So fleet allocation status. Will contain the game server that, in fact, actually, that's a game server that has been allocated from a fleet. So, in theory, this should really just be game server pointer to a game server. That could then be populated when it's good to go. So that should be okay. All right, so what we can do now is actually generate our client, which is kind of cool. So let's do that. That's all looking pretty good. What do we go? Make gen. So like I said, I have a make target for generating the custom resource definition clients. It does basically just calls the same thing as the CRD stuff. So gen CRD client.sh, and we'll get a bunch of code getting generated at this point, and then we'll be able to work against it, which would be quite nice. All right. So you can see, like, if we have a look at our Git status, right, like there's a lot of fun stuff in there that's been generated. If we go and have a look, where are we? Client, here we go. This should all be different now. Yeah, client set, where are we? I'm trying to see if I can find a good version of this. There's a whole bunch of new stuff in here. So we'll have listers, here we go. So like fleet allocation has a new thing, right? So we can like get at fleet allocation values, all this kind of stuff. There's lots of goodies in here now that we can access this as an API that's available once we've installed this custom resource definition anyway. So that looks pretty good. I'm actually going to, excuse me for a minute. I need to check out -b feature fleet allocation. Let's actually work on a new branch. And then we'll commit this code first pass at creating a CRD for fleet allocations. Cool. We're going to make build. Yeah, we're going to do that and have that run in the background. So we're going to run this in the background and have that pop up. And what should then happen is we should be able to actually request an allocation and see if it exists or not. It's going to say we don't have any because we haven't created any, but at least then we have something. Okay, so we'll let that run in the background. Cool. All right, we'll just close all of that off. Awesome. So that means that once we have this code working and running, we can create fleet allocations, and we can just do stuff with it. And it's kind of on us to actually do a thing. It's entirely on us. This is kind of where you get into the controllers part of things. So you might have seen, that we've done it in previous streams where we're writing controllers, or you might see me gone through the code for Agones. And it's really just a whole bunch of controllers that look for events of those custom resource definitions and when things happen, and then do things to them. All right, so where do we want to start next? Okay, so that's gonna run in the background. It's doing a bunch of stuff. I'm just gonna let that run, and then when that's complete, we'll come back to it and see whether or not it seems to have worked. And I will distract you with other things in the meantime. So we've got a pretty okay package management here, and now that we're starting to spread out, I'm wondering whether we want to consolidate some of this stuff a little bit. You can see we've got fleets, we've got game servers, we've got game server sets. Now I'm almost wondering whether these should be amalgamated into a controller sub-package above it. Ooh, maybe we should. Let me actually, see, these are the thoughts that happen while I'm doing this. All right, I'm just gonna write a note to myself. Think about condensing or moving game servers, fleets, etc. into a controller parent package. All right, because, and the reason I say that is because now, whoops, that's not what I want. I want a new package, a new directory, sorry, because we're going to have a fleet allocation, and we're just going to follow the pattern of, excuse me, of everything else. Now, this one is going to be slightly different from some of the other controllers we looked at before. So this should be interesting. So I'm actually just going to copy some of this stuff across because I'm lazy or efficient, depending on how you want to do it. So this will be fleet. This is just my documentation package. Fleet allocation handles management of allocating game servers from running fleets. Cool. Cool. All right. All right, that's a good start. All right. I'm going to need a new Go file, and we will call it controller. An empty file. Lovely. I'm going to steal some stuff from some other places, and it's going to make life easier. Okay, so I'm not going to worry about that. All right. I'm going to grab a basic data structure. So this is the data structure I've been using for pretty much all my controllers. And then we'll, we'll work out which parts of this we actually are going to need as we go through. So, this is actually a really interesting question. So what am I going to want to do? So the theory is, or that I'm working on here, is that somebody's going to create an allocation. We're going to intercept. We'll talk about how we do that in a minute. We're going to intercept someone's created an allocation. We're going to say, okay, what fleet is this for? We're then going to grab whatever game servers are available for that fleet. And then we're going to say, we're going to grab whatever game servers are available with that fleet, and then we're going to grab one of those, and we're going to set that to allocated, and we're going to set that version to this allocation, and then we're good to go, essentially, I think this works. Excuse me. So, what do we need to have access to? This is an interesting one. Okay. So, logger is just a standard logger. Custom resource definitions, we want to be able to have that because we want to wait to make sure that our custom resources have been installed. So we're going to do that. Game server sets are something we will care about. So game server sets back fleets, but don't worry about that. That's not a huge thing. There's a bunch of cache syncing we can do, but I don't think we actually need it here. So I'm actually going to get rid of that. Fleets we need to be able to get at, so we just need to be able to list them. So going through the listers is actually important. Listers are the way we look at the internal cache that we have in ClientGo here. And hold on, I'll ask that question in a sec. And fleet synced, we don't care. Now, I don't think, normally when we do controllers, we often have a worker queue that rolls around and makes sure everything is okay. I don't think we're going to need that here. Recorder is for we can put events against stuff, but we'll look at that in a minute as well. All right. All right, so game server set lister, it's there. All right, cool. I'm going to import alias. All right, so everything's there. All right. V1 alpha 1, and I think we will need a fleet allocation getter. All right. So we've talked about getters versus listers before. Getters are basically direct access to the API. They're less scalable than using the cache. And so we need a allocation. Fleet allocation. Yes, that's right. And this is all generated code from the ClientGo. Nope. Fleet allocation. I've called the wrong thing. Getter. There we go. Fleet allocations getter. Nice. And then fleet allocation lister. Cool. What do I normally call V1 alpha 1? Call it getter. All right, cool. Let's do that. Lovely. Okay. I saw there was a question there. There's two questions. Okay, Newbard64. What tools do you use for testing in Go? Minimock or something else? So This is an interesting topic. So for testing in Go, I just use Testify, which is a library. Where are we? Testify. I literally just use the test assertions. I find them really useful. Some people will rail against that, which is fine. I just find it a nice, short, easy way of doing things. Like, is this stuff equal? Outside of that, it's all just standard Go testing. That's all it is. It's nothing special. If I need to mock stuff, that means I need to write interfaces, so I just do that. If I need to mock functions, I need to make sure I need to write a function interface, so I just do that. Nothing more special than that. The client Go stuff, this like add reactor stuff that we've actually looked at previously, the proxying for that, that's a faking library that comes with client Go, so that's ready to go. Dan Slow says, what's the hotkey to align all variables? That seems super useful. So yeah, IntelliJ, I think I've got mine set to Control-Shift-F. That will align everything. If you're writing Go though, what you actually want is either Go format or Go imports is also really nice too. Go imports will do all your import statements, and that will do the standard Go like formatting, and you see that just flipped there. That's the better version. I'm just using the IntelliJ one just out of the box because that's just a bit easier than me flipping over. A lot of editors will do Go format or Go imports out of the box as like a control, like as soon as you save and do it. Just the way I've set this up, and I'm not going to go into details on that. That doesn't necessarily work for my particular setup. There's nothing against that though. That definitely works, and it's quite nice. All right. So that gives me, I think, all the pieces that I might need. All right, let's take a pause there for a sec. So what I'm just going to go back to real quick is we should now be able to get allocations, and it should say I didn't have any, right? So if I ask for something I don't have, it's going to be like I don't know what that is. But we can actually see now we have this thing called allocations, which we didn't before, and that's kind of cool. The demo I was going to show you earlier, which I'm going to do really late now, is the fleet demo. So let me actually show you that. So I have a... which way do I go? I have a fleet definition in examples of the simple UDP packet here, where I've got a fleet of 2 of these particular game servers. It's just a simple, hey, can I receive a UDP packet or not? So... let's actually create that simple UDP server fleet. So just so you can see this in action, you can get a bit of an idea of what's going on. If I go kubectl get game servers, you can see now I have these 2 game servers that are available, and I can do stuff with them. I'll actually describe game, just use the shorthand, game server, simple UDP bash 5. There we go. You can see that the game server is up, it's ready, see state ready. I've got an IP and port that I can connect to, I can do stuff with. By the same token, if I want to kubectl edit, there's a few different ways I can actually edit these things. Again, I can do this all through the API as well. Fleet, there should be, what is it, simple? Really? I'm not going to get code completion on edit? What? Simple UDP. Now I'm just sad. Oh no, there we go. But I can actually kubectl edit too, which is kind of nice. And I want to say make this 4 instead of 2. That'll push that up. So fleet, that's edited. So now if I get my game servers, I actually have 5, but it'll actually drop down to 4 at some point soon. No, it's 4. Sorry, I lied. So that's actually, now we have 4 game servers. If I look at the backing pods, you can see they're all running. So what I'm trying to do here with my allocation is actually pull out one of those fleets, one of those game servers that fleet is controlling, and say like, hey, this thing is allocated. So cool, we have a fleet, and that all works, which is great. That's pretty awesome. Okay, so we have a controller. I'm just going to drop a to-do in here. Integrate the controller with the main binary. At some point, we'll get there. We will get there. Okay. The other thing I will then steal is my function for new controllers, and I'm just gonna, I'm gonna grab the whole thing because I'm lazy, and we can pick this apart. No, actually, yeah, no. I am gonna steal the whole thing. A lot of this is not gonna apply for this. Nope, I changed my mind. right, how do I want to do this? All right, so we're going to create a new controller. It will returns controller, where are we? Returns controller for a fleet allocation. We're going to take in a bunch of variables. We'll come back to that, and we will return a pointer to a controller. Cool. Good start, right? So we're going to need to grab a whole bunch of stuff. Afraid Duchess says, a fleet is just a collection of a bunch of game servers, yeah? Yeah, exactly. A fleet is just warm game servers that are sitting there waiting to be given to somebody to play a game on. That is all it is. We could actually fire them up individually, but depending on the time that it takes for a game server to come up or shut down, that can be slow. By the same token, it's a little easier to sort of do some auto-scaling types of things when you're dealing with fleets, because you actually can see very easily how much memory and CPU resource you have left over and stuff, which is quite nice. All right. Okay, so I just I need to do a bunch of just housekeeping stuff. Oh my god, yeah. Maybe I will steal. Let's go new controller. Okay, here we go. This actually has a bunch of stuff in it that I might want, and a bunch of stuff that I do not want. So I'm going to pass in a webhook. What's the things I need? So we're going to talk a little bit about why that's important in a minute. We'll come back to that. We'll need the ext client and that stuff. So we'll go, I think that's all the things we'll actually need. All right. That's right. And that's right. And that doesn't know what that is. Okay. Interface for external version stable. Yeah, that's what it is. I think that's right. I will actually double check that over here. So what did we just pull in? Oop, I just broke something. What did I break? Yeah, I did something to this. I don't know what it was. All right, you know what? Git. Yeah. Something is not happy with me. Oh no, it's fine now. That was weird. Anyway, here we go. That's the one. All right, I can just steal this too. And then I'll tell you, and that's the same? Oh no, it's different. Okay, that's fine. Okay, so what I did here, we're gonna ignore this one for now. We'll come back to it, although we only have 17 minutes left. Oh no! ext client gives me access to what custom resource definitions exist. Agones client gives me access to basically all the Agones stuff, which I have here, and the informer factory gives me access to informers, which is a shared cache of what's going on inside the system. Alrighty. I'm just gonna steal pieces from here. This is there goes my dog. Just gonna bark at something, right? All right. Return C. So that'll make that happy. So let's populate all these values inside here. All right. First is a logger. Logger equals. How do I do this? I actually forgotten. Where's my logger? Oh, apparently I do it after the fact. Okay, let's do that. So I have a standard logging library that gets populated. I use Logros. I quite like it. It spits out stuff in a JSON format, and so I just spit this out here. This is gonna be. I have my own runtime package that does stuff. All right, cool. So there's that. So there's the logger. CRD getter will be. Actually, and I can just steal this stuff from over here too. So it gives us access to that. Game server set lister. Oh yeah. So game server sets. All right. Whoops. Here we go. Game server set lister is Agones form factory dot lister. There we go. So that gives us access to that. We have a fleet lister. This is all very boring stuff. Sorry. Agones informer factory dot stable. All right, so we're gonna pull some of this out. Dot v1 alpha 1 dot fleets dot lister. Let's pull that out. v1 alpha 1. We'll call that a variable and all two occurrences, and we'll call it blah 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 blah. Agones. No, Agones client. What do we want to call it? I don't know. What do we want to call it? Agones informer. Let's do that. There you go. Do I do anything over here? No, I don't. Okay, that's fine. All right, so we need a fleet allocation getter, which will be actually the Agones client, because we need this direct connection so that we can actually do updates and stuff. Oh, you asked a good question. Why do I document it that way? First of all, the linter will pick up if I don't write new controller up the top. So having something there is good, basically. And also, if there is anything else I want to potentially verify, like the linter will pick up if this is like, if that's not there, my test will actually fail because the linter picks up that I haven't written anything for it. So I like to make sure. I'd rather err on the side of, hey, this is like blurringly obvious than not have anything at all, and then that becomes a thing. That's not right. What have I done? No. V1 standard 1. There's that. Oh, actually, it's just that. It's just that. There we go. So fleet allocation getter actually is an interface, which is kind of fun. And this actually, while it does more things than the interface, that one actually has the piece that I need, which is basically be able to get fleets. But yeah, that's a good question. I know that looks kind of obvious, but the linters, the standard Go linters will be like, that's not, there's nothing there, that's bad. And so it's good to say what's going on there. And then what do we need? We need a fleet allocation lister, which will be Agones informer dot fleets dot lister. Beautiful. Okay, so that's pretty much why are you complaining. Cannot use Agones fleets lister as type fleet allocation lister. Fleet allocation lister is a fleet. Why not? Fleet allocation lister is an interface that has list and fleet allocations. Fleets dot. Oh, you know why? Because it's a fleets, not a fleet allocations dot lister. That's better. Okay. That all looks good there too. Cool. The only other thing I haven't done is added the recorder. I'm just going to copy paste that and not really worry about it for now. What this does, and I'll actually show you what this does actually. It's kind of nice. I think it's that one. Let's actually, ooh, looks like I need something here that I don't have. All right, that's actually good to know. All right, so let's just set this up, make sure it's, nope, I wanted you to bring me up here. There we go. Set up the import alias. There we go. That's good. Core v1, event source. That's that one. Yep, that's that one. Core v1. I'm going to call core v1. And we will need a Kubernetes client. Look at that. All right, fleet allocation controller. Bear with me one sec. I'm going to steal that Q client interface from here. And I normally put that there. Okay, that works too. Here. Actually, no, I don't need that stored in here because I'm not doing anything with it, but I do need it here. Okay, and so that will now work. Okay, so this event broadcaster here is actually kind of neat. So I'll actually show you what that does. So we looked at fleets earlier, for example, and we looked at describing them. If we have a look at our fleet simple UDP, you'll see down the bottom here this event section where we're actually putting some interesting information about exactly what's happened to the system. We'll see very similarly if we describe a certain game server, pick a game server. Is it going to give me options? It is going to give me options. BTW, CPL. Again, right, you see this event section down here, and you'll see this event section pop up in a variety of places across Kubernetes. And this is a really useful way to see exactly what's going on. So we can use this event recorder to put these values in here. So it's just kind of plumbing, just getting the plumbing ready, and that's kind of getting that ready to go. Okay. Whew. That was a lot of plumbing. We got started though. I'm just looking at the time a little bit. What we'll also do is we'll run go imports w package just to order everything. This all looks the same, but this will reorder our import section up here. So that's all looking better. Okay, so we've got sort of 9 minutes left. That's a kind of nice, good start to just getting the basic values set up and also generating the clients, which is super nice. What we'll end up doing next, and I'm going to try and stream it because it is actually quite interesting, though we'll see if I end up working on this some more today. We'll see how we go. Is we'll want to intercept when a fleet gets created. And that's going to be the next fun trick. The way we do that, just to give you a little bit of a teaser, there's a thing called a mutation. Let me make sure I get this name right. That's not what I want. Where are we? It is called, and we have some examples of it actually already. Let me make sure I get it right. Helm templates. In fact, actually, we can do this right now, which is kind of nice. We can extend this out right now. There's a thing called a mutating webhook configuration, or mutating, what's the word I'm looking for? A mutating admission controller. Basically, its job is to intercept when resources get created, regardless of what they are actually, and fire a webhook that enables us to actually change the values of things on the fly. It's actually kind of cool. I can see Nidabde says hi. Hello back. This is hugely powerful. Also potentially a huge foot gun because you don't want to like just change things on the fly and see things go weird. But it's hugely powerful. We use this in our game servers for setting default state for those. But what we're going to do here with with our what's the word I'm looking for? With our fleet allocations is intercept when they come up, and then when they get created, we're going to actually then do a thing, right? We're going to actually go have a look at the fleet and then make sure that those values are ready and they're coming up. So to actually do that, there's a lot of there's a mutating webhook configuration. We've already set up the webhook. See it here. It's actually backed by a Kubernetes service. This CA bundle will eventually change. This is actually the public key encryption, so like security, yay, that's always good. And it hits this mutate thing. So what I've actually set up is a bit of plumbing behind the scenes that says, okay, all the mutation webhooks go through a single path, and then we'll pass those out to handlers that need to be able to handle them. I've sort of already set up that plumbing, so I can just add things to this, and it won't mess things up. So we can actually add fleet allocations here. And then whenever a fleet allocation gets created, then, excuse me, whenever fleet allocation gets created, we can intercept that, run the webhook, and make changes, which is quite nice. Now, so that kind of, or it is there. So that's actually what we need to do. So the nice thing is we have this webhook library that I wrote, that basically sets all of this up, and then we can actually, where are we? We have this nice add handler function. that we can add our own handlers for, and then intercept these events and like basically say, hey, for these particular types of resources, we're going to care about it, and these types of operations, we're able to do that. If we want to actually see an example of that, just to tease you a little bit. Nope, that's not what I want. Package, fleet allocation, fleets. I do this in game servers. We'll have a look at our controller. So where's our webhook? Here we go. Webhook, add handler. Right. We've also got validation handlers. That's how to do some more complicated validations. We'll look at that for this definitely in here too. But here we can see, okay, for mutate, just handle when we get a type equals game server come through. It's a create operation, and we're gonna do. We just have a handler which takes in this thing called an emission review, and we'll step through that in a minute, in a later date. But that I think is actually, where are we? So let's look at what we need to do. So we need to add a mutation handler so that we get a game server when a fleet allocation is created. We also add a validation handler, so you can't edit a. Actually, that's a good question. Maybe we won't do that. Let's not worry about that for now. I was actually thinking you probably shouldn't be able to edit a fleet allocation, but we'll need to be able to edit a fleet allocation, so we might come back around to that. Actually, I would say to do add a validation. Say add validation such that you can't change the fleet name on an allocation. That is actually very true. And then there's a bunch of work back there, but we're coming up on the hour, so I'm actually going to stop things here. I will add our work and we will get committed. Start on the controller for fleet allocations, and I will push that up so you can see that get push -u. If you're at all following along, which you may want to do or not, you can do that on my fork, which is, strangely enough, Mark Mandel. Not on the issue. There we go. Here we go. There's my fleet allocation. So that's my branch that I'm working on right now. So if you want to follow along for the code that I'm doing, yeah, we will need to wrap up in a couple of minutes, unfortunately. But that's a good start. I'm gonna keep working on this. I'll try and do some more streams this week as well to keep this work going. Obviously, I'll keep working on it as well and keep you all up to date. If you want to know when some impromptu streams are happening, yeah, definitely follow me on Twitch. You can see the details below. Or follow me on Twitter, which also have links below. Or if you want to learn more about this project, definitely let me know. That's great. I've been thinking about some other streams. I've been thinking about doing like maybe just a basic stream on like how to get started, just like the basic setup of tooling for Agones as well. I thought that might be interesting, and then get that up and running, and then do something simple, just to show how that process of like having nothing to getting started. If you like those ideas, definitely let me know. Reach out to me on Twitter or on here on Twitch, or on Slack, or anything like that. And yeah, I will get this edit and up on YouTube at some point soon too. But thanks all for hanging out with me. That would be great. And I really appreciate you all taking the time to chill. Afraid Duchess, that'd be awesome. Okay, cool. I thought that might be an interesting idea. I was thinking about that this morning. I figured that might be a really good video to do. All right, sweet. Thanks for hanging out with me. Thanks for being such a wonderful audience. I really appreciate all the questions and hanging out and dealing with my dog barking in the background. And I will catch you all hopefully later this week. If not, I will see you all Tuesday next week at 9 a.m. Pacific. All right, cool. Thank you very much.